Assalamualaikum and good morning guys. So we talk about microencapsulations, the processes and uses. Okay, so previously we have talked about the drivers of microencapsulation. Now we're going into the processes again, not in details, just for us to understand the basics technologies. Okay, right, so at most basics, the encapsulant materials can be selected from, this proteins, carbohydrate, lipids, waxes. You can use either alone or in combination depending on your requirements. And the choice of materials will depend on the properties of the core. If you're trying to stabilize omega-3 fatty acid, for instance, you need different kind of material. If you try to protect green tea extracts, the material will be different. And this material should be film forming, it should be pliable, it should be odorless, and it should also be tasteless and non-hygroscopic, because you don't want moisture to come in. Okay, and for the suppliers, you as the functional food technologist, you have to communicate with your suppliers. They know a lot about the technologies of microencapsulations, even though actually they borrow the knowledge from pharmaceutical industries. So they know about the properties of the core, physical or chemical. They know the encapsulant materials and how to achieve functionality required. Maybe the halal status. Sometimes you are not certain whether it is halal. You can see from the materials of the encapsulants, and whether there is going to be interaction between the core and the matrix and the environment, the stability of the microcapsulated ingredient in storage and when incorporated in the food matrix, and finally the mechanism that control the release of the core. Sometimes there is one layer, sometimes there is additional layers, maybe 2 or 3 layers. So with this information from the suppliers, it will assist us in product design and development. So for us, it is important for us to know the basic exposure on this microencapsulation and processes. Okay, let's go into typical material use as encapsulants again, because we want to apply this in food. It should be food based. It should be carbohydrates, protein, and also lipids or waxes. So like native starch, modified starch have been used before, resistant starch, even dried glucose syrup. So there are many possibilities. Carbohydrates can form gel and they can form glassy matrices that is have been exploited for microencapsulation of bioactive. Same thing with proteins, things like sodium caseinate, whey protein, isolated wheat proteins, soy protein, gelatin. This is the reason why we need to know if the halal status, where this gelatin come from, and then the zein and albumin, expensive protein. Protein use because of their excellent solubility in water, good gel forming, and also film forming, and protein can emulsify as well. So proteins are often combined with carbohydrates because in order for you to achieve microencapsulate oils and fats. Protein also has property that results in immediate release of the core, because it can be easily digested in our body, so it releases the core. And finally we have lipids and waxes. It can be vegetable oils, hydrogenated fat. So lipids are generally used as secondary coating. If you see here, the materials, the layer, there is one layer and then there is another layer outside. That's what we call a secondary layer. This is to be applied to primary microcapsules or to powdered bioactive core to improve the moisture barrier properties. Okay, right, next, the processes. There are two, can be mechanical processes or can be chemical processes. In fact, there are so many processes, it is not within our forte, but we are familiar with spray drying, we are familiar with emulsification, co-observation, not so much in our forte, but we should know, because spray drying is the most common, so that's good. We are very familiar with spray drying. And then simple co-observation is widely used in industries. Of course, there are others like fluidized bed coating, complex co-observation, that if you have time, you can read all of these processes. Yeah. So our learning outcome is, without going into details, we do not know how to process this. But we should get exposure on the how this microencapsulation can be achieved, either using mechanical processes or chemical processes. I will give example of spray drying and emulsification, and also simple co-observation later. Okay. But first, the choice of methods will depend on the properties of the core, of course. Also, it depends on the encapsulant materials, and finally, it depends also on the target food application. So all of this you have to discuss probably with your suppliers, even though they are the one who doing this experiment, whether what kind of method to use to produce the functional ingredients, what kind of encapsulant material that they're going to use, and you as the functional food technologist, you have to guide them sometime what kind of food that you have in mind as a target applications. But most of the time they already think about this, they already produce the functional ingredients to protect certain bioactives, and most of the time it is already in good hand. Yeah, the technology is already established. But example here is the process of spray drying combined with emulsification. So in this case, the oil phase example can be beta carotene, can be lycopene, can be omega-3 fatty acids. So this oil phase will be homogenized together with the aqueous phase. This is when they add the encapsulant material. In this case, could be maltodextrin, and then an emulsifier. Yeah, the 5-point star there. So after homogenization under high pressure, you will have this emulsion. We call this emulsion as oil in water emulsion. The yellow oil in the middle there, being surrounded by the first layer of encapsulant material plus emulsifier. Therefore, you're going to have even distribution of this bioactive compounds. Yeah, and the aqueous, of course, will be surrounding the microcapsules. Of course, they are going to subject all this into spray drying, and zoom, after spray drying you will get yourself powdered functional ingredient. So hopefully this powdered one can be soluble in water. Second example will be use of simple co-observation, or sometimes it is called polymer coating, which is a chemical process. So you start with a normal emulsion, regular emulsion, or lyophilic emulsion, colloid. Lyo is a solvent. So this encapsulant material, like soluble polymer, like proteins, plus emulsifier. You know that protein is soluble, but protein can become aggregated later on. So there is a strategy here. The pH or temperature is modified to make the polymer, like protein, to become insoluble. So when the protein become insoluble, it forms a separate phase that coats the emulsified phase. So now you have yourself insoluble protein as coating, and therefore protect the bioactives. Next they do is they add chemicals with a good affinity for that particular solvent, the lyo, and then this chemical will wash away the solvents. So you have yourself the final products there, coacervate. So encapsulants or polymer coating prevent coalescing, so this oil will not form a big lumps of oil together. They are now being protected. So you have colloid chains. Okay, definitions given there: and aggregates of colloidal droplets held together by electrostatic attractive forces, or a cluster of droplets separated out of lyophilic solvent. You remove the solvent out. Okay, that's how coacervation is done, but it's a chemical process by using the solvent and chemicals. Okay, in conclusion, there are many bioactive compounds. Some are hydrosoluble, that's easy and good. Second, it can be liposoluble in oil. Third, it's going to be insoluble. Okay, so therefore they must be encapsulated for proper and successful incorporation into food. You cannot simply dump into the food without a proper microencapsulation. It will not disperse easily. Uneven distribution is bad for taste, it's bad for shelf life, etc. So strategies to fortify individual categories of food products are described in patent. You can read patent publications or as trade secrets. I mean, you have to work in that particular companies or industry only to find out the trade secrets. 3 types of bioactive compounds to be protected: desired release profiles, biodegradability, and biocompatibility of the matrix. Final properties of food matrix need to be properly defined for deciding the microencapsulation techniques. So these number 3 conclusion is the jobs of the suppliers, our suppliers of functional ingredients. These people are, they come from pharmaceutical industries or nutraceutical industries. Okay, finally, I'm just going to share this table how microencapsulations help in our case. Number 1, in vitamins and mineral, because they are sensitive to temperatures, light and moisture. So the issue is susceptibility to degrade during processing and storage, and react with food components. So this issue causing the manufacturers to add more. So they have no choice, they have to put in higher levels required to compensate losses. So by using microencapsulation, the solution was there. The level added are now according to a recommendation. You don't have to add so much anymore. Okay. Second example is omega-3 fatty acids. We know it can oxidize if exposed to oxygen. When it is oxidized, it produces fishy taste, odor. You don't want to drink or to eat this particular food, and it will affect acceptability and shelf life. So what is solved? By protecting the sensitive oil, we can protect from oxidation, masking the taste and also the odor. So we have the example emulsion-based technologies and spray drying. Finally, probiotics. We want probiotic to be released away from the food, and then not in the mouth, hopefully not in the stomach because of the acid, but later in the small intestine and large intestine. So probiotic is sensitive, alive, that must remain alive during processing, during storage and gastric transit. So there is always efficacy issue. Some of probiotics are not alive, so you cannot claim the content, but most of the time you claim because you do not know. But technologies are there. They have solved the problem by using microencapsulation, spray drying, spray coating, extrusion, emulsification, the survivability of in vitro digestion, protection of live culture during processing. So if you buy 6 billion, you put into your product 6 billion, very likely now that you have 6 billion being transferred into your digestive system. Okay, 15 minutes already. Conclusion, you must deliver what you promise. Bioactive compounds, health benefits. Should stability of bioactive compounds fail, therefore no health benefits, communicate with your suppliers to solve it. Okay, it could be the problem with the ingredient, it could be the food metrics, or it could be the processing. It is not possible to directly add bioactive compounds without microencapsulations. They are sensitive. This is the reason why you learn all of this interaction in food chemistry. Okay, so that's all the lecture for today. Thank you. Happy learning. Bye guys.